Okay, so here's number one. Number one out of your practice FRQs. Okay, this says a particle travels on an x-axis, so its velocity at time t is given by this for this interval. Okay, now before I go on, I want to make sure we understand the problem and what's happening in our problem. It's talking about a particle. Now, when I introduced to you guys displacement and total distance traveled, I talked to you guys about a trip that I went on with Javi. We started at his house, and we left the house. Now, 10 miles away, we stopped because Javi forgot his cell phone. And so we're on our way back, and then Javi goes, oh, wait a second, my cell phone's in my pocket. And so then we stopped right here. Look at that car. We're going to call that an elephant car. Okay, anteater car. I like it. Okay, now, when we deal with integrals, integrals read speed differently than we do. If I was working with a function, an integral function, it would have said that we're going a positive speed right here. So that's a positive distance. But then when we turn around and start coming back, the integral would say, oh, you're going a negative distance now. You're going a negative speed. Does that make sense? It reads your speed as positive or negative, which is we're not used to it because we don't know negatives. We don't never use negative speeds. So let's pretend that our distance was 10 miles right here. And then when we went back 7 miles, that's when we stopped. Okay? How far are we from the house? 3 miles. Now, if I did the integral of this problem right here, I would get 3. Because it knows that this is positive distance and this is actually negative distance. And so our displacement would be 3 miles. Okay, that's displacement. Are you guys with me? Okay, does that make sense? Okay, so let me draw one more thing. I'm going to try to mathy up this problem right here. So we went a positive speed, or whatever. We went positive, and we had a positive distance. We'll say this is our positive distance. We'll say that's 10. And then we went a negative distance back, and that's the 7. So this area is 10, and this area is negative 7. And if I found the integral between this and this, I would get a positive 3. Does that make sense? That is displacement. Okay. This says, for what values of t is the particle moving to the right? Now, if we look at our anteater car and our trip with Javi, we're going to the right at the beginning of the trip, right? That's when our speed is positive. And then when we start going backwards, our speed is negative. When we start going to the left, our speed is negative. So this question is asking, where is our speed positive? Where is the velocity positive? Velocity is f prime, isn't it? Right? Velocity is f prime. Okay, so all you need to do right here is you need to take your velocity function, which is 1 over 2 minus sine t, and you need to find out where this is positive. Now, we've always worked on it like this. We've made it equal to 0, so then we can find the points where it equals 0. If you do that, if you work this out, you move that 1/2 over, then you multiply both sides by negative, you get 2 values. You get a value there and a value there. I'm going to call those critical points because that's what we've called them before. And your question is, where is it positive and where is it negative? And if you actually do this, you will learn that it's positive in this interval, negative in this interval, and positive in that interval. So now I know where it's moving right. It is moving right in this first interval, and it's moving right in the second interval. I'm not going to work it all out because that's you. You gotta practice that. Okay, so that's moving right. Now it says if the particle is at x equals 3, what is its final position? Now what you need to know is its displacement. Exactly where is it at the end of the time? The end of the time is pi over 2, or sorry, 2 pi. Let's take this to our Javi story right here. My house right here, or his house, we first said that we were assuming it was 0, I suppose. But let's say it equals 3. Where is the car's current position now? It is 6. Okay, and how do we know that? Because we know this. We know the displacement. Now, we were talking about it earlier that we can find displacement by finding the area underneath the curve between two boundaries. So that's what we're going to do. We're going to take our speed, which is 1/2 minus sine t, and we're going to find the area underneath the curve between 0 and 2 pi. Do you guys see 3 anywhere in this equation? No, it's not. Okay, because you're just looking for displacement right now. So this is b. And so once you do that, once you figure out the displacement, I think you get pi. Once you do it all out. And now, what's my displacement? Or where am I located? I'm not located at 6 for this particle because it's not, the displacement's not 3, it's pi. So where am I located then? We started at 3. You would add pi to it. This is where your current location is. All right. So now what about C? This is where it gets gnarly. D is actually a nice little question. Not gnarly because it says, what is the total distance? Now, if I look at our scenario right here, what is the total distance that we traveled in this scenario up here? It was 17, right? It's not 3. It's 17. We traveled a total distance of 17. Now, how did we get 3? We got 3 because the 7 was negative, right? It saw that distance as negative. And that's what's going to happen to this function. Between this number and this number, these two critical points that we found in the first problem is seeing that area as negative because it's below the x-axis. So we need that area to be positive. So here's the technical way to write it. You actually don't need to have this first way to write it on your paper, but this is the technical way to write it. From 0 to 2 pi, I want the absolute value of this. So wherever the area is negative, I want it to be positive. That's what the absolute values tell us. So this is when the problem gets long. Because really what that means I need to find the integral from 0 to c1. I need to find this one. And that's going to be positive, right? And then I'm going to add to that the integral between c1 and c2. But wait a second, if I find the area between C1 and C2, that would be negative, right? So I need it not to be negative. So I'm going to put a negative right there in front of it, because that'll undo the negative. It'll make it positive. And then I'm going to add one more integral, and that's the last part of the area, and that's going to be from C2 to 2 pi. That will give you the total distance traveled. Okay, I'm going to leave it at that. You guys write that down and work on that. Last one says, when t equals pi over 4, what is the speed of the particle? Is the speed of the particle increasing or decreasing? Is the speed increasing or decreasing? What's that called? When your speed is increasing, what are you doing? You're accelerating. If you're decreasing, then you're decelerating, right? So we need an acceleration formula here. What is acceleration? Double prime. If this right here is f prime, how would you find double prime? You take the derivative of that. Does that make sense? Okay, so you take the derivative of that. So we're going to take the derivative of velocity here. And then you're going to plug in pi over 4. And that's going to be your answer. That'll tell you if you're increasing or decreasing. If it's positive, then you're increasing. If it's negative, then it's decreasing. Again, guys, we're looking at concavity.